formal charge. Now, if we look at, let's say, the molecule of carbon dioxide, then the total charge on, on any molecule is 0. And supposing if we take, let's say, an ion, like a carbonate ion, then the net charge on carbonate ion is -2. But supposing, let's say, I have a molecule of ozone, and this ozone molecule, I want to find the charge on one particular oxygen atom. So what is the charge present on an individual atom? That is called formal charge. So formal charge, you can say charge assigned or charge present on an individual atom. Atom in a molecule or ion. So that is the formal charge. Now the formula for calculating the formal charge is total number of valence electrons on an atom minus number of non-bonded electrons, that is electrons which will not participate in bonding, non-bonding electrons, or you can say the lone pair of electrons, minus half into bonding electrons. Now let's understand this by an example. Supposing I have this molecule of ozone. Now this will be, there's a double bond. So this consists of 4 electrons. So this will have 5, 6, 7, 8. Then of course this particular atom will have, it has double bond on left hand side and a single bond on right hand side. So 6 electrons are involved in bonding. So this will be, it will have 2 electrons, one lone pair of electrons here, and this will have 6 electrons here. That is 6 electrons which are not involved in bonding because it is bonded to the other atom by a single bond. If this is 1, this is 2, and this is 3. Then let's calculate the charges or the formal charge on each of the oxygen atom. Now let's say we have this oxygen atom 1. Let me draw the figure once again. The figure was, this is O double bond O, single bond O, 2, 4, 6, here 2, and here 4. So if I take this atom, oxygen atom, then formal charge on this oxygen atom is number of valence electrons, which is 6, minus number of lone pair of electrons, that is non-bonded electrons. So number of non-bonded electrons you can see are 4, minus half into bonded electrons. So half into, there's a double bond over there, that means half bonded electrons are 4, because each bond consists of 2 electrons. So this will be 6 minus 4 minus half into 4 is -2. So this will be equal to 0. So the formal charge on this first atom of oxygen is 0. Now let's consider the second atom of oxygen. So this is, again I'm drawing the diagram here. Here we have it. So we'll find out the formal charge on the second atom. This is the second atom of oxygen here. So formal charge will be equal to total number of valence electrons on the second atom, again is 6, minus number of non-bonded electrons. You can see non-bonded electrons is 2, minus half into bonded electrons. Now you can see there's a double bond here and there's a single bond here. So total number of bonds are 3. That means there are 6 electrons. So this will be equal to 6 minus 2 minus half into 6 is 3. So that is 6 minus 5 is equal to 1. So the formal charge on this second atom of oxygen is 2. Now let's calculate on the third atom of oxygen. For convenience, I am again drawing the diagram. This is O double bond O. Four electrons here and 6 electrons here, and this is my third atom. So formal charge will be equal to number of valence electrons is again 6. Number of valence electrons will always remain the same, minus total number of non-bonded electrons. You can see it is 6 over here, minus half into bonded electrons. There's only a single bond here, so there is 2 electrons here. So 6 minus half into 2, that is 1. So this will be minus 1. So formal charge on the third atom of oxygen is minus 1.